Welcome to our channel, where today we're diving into the intriguing world of JavaScript generators and how they can simplify iteration in complex front-end applications. Imagine being able to control the flow of your code execution, pause it, and resume it whenever needed, all while managing asynchronous operations smoothly. That's the power of JavaScript generators. In this session, you'll gain insights into their syntax, functionality, and how they can streamline your coding processes. Whether you're building dynamic web applications or handling complex data flows, understanding generators can be a game changer. So, if you're looking to enhance your JavaScript skills and make your code more efficient and maintainable, stay tuned. Don't forget to subscribe to get more high-quality tutorials that keep you updated with the latest in tech. Let's delve into the theory behind JavaScript generators. Generators are a special class of functions that can be paused and resumed, offering a more flexible way to handle iteration and asynchronous operations. They are defined using the function syntax and utilize the yield keyword to produce values one at a time. Unlike regular functions, which run to completion, generators can be paused in the middle, allowing other operations to be performed before resuming. This makes them incredibly useful for managing workflows that require waiting for asynchronous events. Think of them as an advanced form of iterators that provide more control over the execution process. By yielding values, you can manage the data flow in a way that regular functions simply can't. This makes them ideal for situations where you need to manage complex iteration patterns or asynchronous tasks. Now, let's look at a practical example of how to use JavaScript generators in a React application to generate the Fibonacci sequence. This example is contained in the Fibonacci JS file, where we use a generator function to produce Fibonacci numbers incrementally. The generator defined within this file starts with two numbers, 0 and 1, and yields each Fibonacci number sequentially. By clicking a button, users can generate the next number in the sequence, which is then added to a list on the UI. This exemplifies how generators can be integrated into React for efficient state management, allowing you to generate values on demand without pre-computing them. This method not only simplifies the asynchronous handling in your application, but also enhances performance by reducing memory usage. Check out the file content on the screen for a closer look. In our demonstration, we'll show how this React app dynamically generates the Fibonacci sequence using JavaScript generators. As we navigate to the app, the interface presents a button labeled Generate Next. Each click of this button calls the generator function, which yields the next Fibonacci number in the sequence. The generated number is then displayed in a list, showing the sequence from the beginning. This interactive component highlights the power of generators in handling iterative processes efficiently, as users can observe the sequence grow with each click, demonstrating real-time state updates within the React application. To wrap up, JavaScript generators offer a powerful way to manage iteration and asynchronous operations in complex front-end applications. By integrating generators into your projects, you can enhance code efficiency and maintainability, especially in scenarios requiring complex data flows or asynchronous event handling. We hope this session has provided you with the knowledge to start using generators in your own applications. Remember, mastering these concepts can significantly impact your development process, making your code cleaner and more efficient. If you found this tutorial helpful, subscribe to our channel for more content that accelerates your learning curve with practical, real-world examples. Thank you for watching and happy coding.